Hello. Okay, so with these videos, I will aim to do a good amount of problems from the book that are not the actual homework problems, but similar to them. So if you look, the name of this will be Homework 5.1a, and then it will have the numbers of the problems that I will do. And then you can easily match up these problems with the problems you have for homework as far as this mirroring the type of problem you'll see. I'm not going to be able to get to like every single one, but hopefully these will give you a much better shot at the types of problems, a majority of them at least, to definitely use your asynchronous time as we kind of have more asynchronous time. I think like cumulatively it's the same, but we're doing it daily now, so there's more like quote unquote downtime during the day. So anyways, all that being said, let's go and get started. So remember when we do an identity, the way that, and this is Mr. Fossey, you may be a student of another teacher. The way I go about it is thinking about the guidelines that we have in terms of skills, and then there's trig skills and there's algebra skills. So our trig skills would be like using our identities, the reciprocal, quotient, Pythagorean, and even odd identities, and using them effectively. There's, again, depending on the problem, multiple ways you go about it. And then there's also algebra skills like factoring, simplifying fractions, combining fractions, and so on. And so when I look at this, I always want to look for what side looks more complicated and then work with that, because it's easier in math to make something complicated look simple versus something simple and making it look complicated. Because if we have something complicated to make simple, we have only a certain amount of finite steps that we could do to make it simple. What if we go the other way? There's just an infinite amount of ways. Like if we start off with 1, we could change 1 into 2 minus 1. We could change it into, you know, uh, 10 over 5 minus 1. You could go on and on. So all that being said, if we look at this problem, I definitely think the left-hand side is more complicated than the right, so I'm going to work on the left. And when I see it's negative in the inside, I'm definitely going to go to my even-odd identities. In my even-odd identities, I go to cotangent, and cotangent negative x is equal to negative cotangent x. And the way that I structure this when I work is I only work on the one side, put an equal sign, and then nothing on the right. And then at the end, I'm just going to draw an arrow down. But if your teacher requires you to write, in this case, the negative cosine x all the way down, then go ahead and do that. So now my goal is to get this into cosine x. So my thoughts are cosine x is much simpler, obviously, than two trig terms, cotangent and sine, being multiplied together. So I want to somehow reduce this or simplify this, and I have multiple things I could do. Well, I don't have any square terms, so I can't use my Pythagorean identities, but I have this cotangent, and then we talked about how all trig terms can be written in terms of sine and or cosine. So I'm going to write sine x as sine x over 1 because I know cotangent in terms of sine and cosine is cosine x over sine x. And then I can, and back up a step, just generally speaking, when we do these problems, you typically do a trig skill and then an algebra skill. Trig skill and then an algebra skill. And within, like, for instance, an algebra skill, you may be doing 2 or 3 steps, but you may get to a point where it's like, I can't do anything else with the algebra, therefore I'm going to look to my trig skills. And that's what I did here. Like, I did a trig skill, and then I also did it didn't go back and forth. The first one was a trig skill going from the first line to the second, and then it was a trig skill from going from the second line to the third. And now it's kind of obvious that we can do an algebra skill, which is cross cancel. So I'm going to cancel those out, and then that just leaves me with negative cosine x, and I'm done because I have exactly what I want. And so what I have my students do is they draw an arrow down and write negative cosine x. So that's number 4. That'll help you with, I believe, number 3. Okay, if we move on to number 8, we definitely have gotten a little more complicated here. And we have 2 terms, and we want it to be sine x. So we have 2 terms on the left, a cosecant x and a cosecant x, cosine squared x. And obviously we want to work on the left-hand side, as that one's definitely more challenging. Now there's different ways we go about this. So I see a cosine squared, and that kind of keys into me, maybe I might want to do Pythagorean theorem on that, or use my Pythagorean identity on that. And our cosine squared Pythagorean identity is 1 minus sine squared. So if I imagined, again, as I teach, I think ahead, and what would you get from that? So if I did cosine, don't write this down, I'm just kind of demonstrating like what I think in my head. If I change cosine squared into 1 minus sine squared, I have this going on, which actually makes it look a little nastier. And then I go, okay, well, what could I do from there? Well, I could distribute the negative cosecant into both terms. And then I see, oh, now I have a cosecant x and a negative cosecant x, and those would cancel. So maybe that might work for me. So I'm going to try this, and I will come back and do this problem again in a different manner. So I just tried this and saw what would happen, thought ahead, and I see if I distribute this, I now have cosecant x over here minus cosecant x times 1 is just cosecant x. Remember, these are just variables, so a variable times 1 is just that variable, or a negative variable times 1 is just that variable. Now if I take the negative cosecant, this term, multiply by that, I have a negative times a negative, gives us a positive, and now I have cosecant x times sine squared x. And so that was an algebra step. Is there any more algebra I could do here? Well, as I discussed, as I was thinking ahead, a cosecant x minus a cosecant x cancels out. And now I'm left with cosecant x times sine squared x. Remember, our goal is to get to sine x. This is definitely looking like we're going in the right direction. And there's no other algebra I can do here. So now I look to my trig skills and I go, what could I do to relate cosecant x with sine squared? Well, I know that I have a sine squared, which is great, and you could possibly use Pythagorean identity, which would be 1 minus cosine squared, but that doesn't really seem to be helping us, because that's kind of complicating things, and we're trying to simplify things, and there's nothing else in there that would suggest that 1 minus cosine squared would help us simplify. But the other thing we could do is we can turn cosecant into sine, and that's where we go to our reciprocal identities. We know cosecant in the numerator is sine in the denominator. So if you look at that cosecant x, that's cosecant x over 1. Any whole number variable is always over 1. There's no other denominator. So we know cosecant is cosecant in the numerator, and cosecant in the numerator is equal to sine in the denominator. And now I'm going to write this sine squared is over 1. Now that I did my trig skill, now I'm going to look to my algebra skill, and I see I have a sine in the numerator. I have two signs in the numerator, one in the denominator. One of them cancel, and I'm left with sine x, and that's exactly what we wanted. Note, I will do this problem again in a different way on the next one. If not, if you're good on this, you can fast forward to the next problem after I redo this one. So last time I used the Pythagorean identity. This time I'm going to look at it differently. I'm going to go, okay, well, I'm going to work on the left-hand side still. This has a cosecant in it, and this term has a cosecant in it, and those are two different terms because they're separated by subtraction. So if I have two terms in common, I could factor out a cosecant. And how is that going to help me? Well, I don't know, but let's just try it and see what happens. So if I factor out a cosecant out of both terms, note if I factor out a cosecant out of here, that would leave me with a 1, because if I distribute this back in, it should give us that term right there. And if I factor out a cosecant out of this term, then I have a cosine squared, or negative cosine squared, left over. And I look at that and I go, okay, now I have a cosecant x times 1 minus cos squared. So I did an algebra skill, factoring. And now I'm going to look at this in terms of my trig, because there's not really any other algebra that I could do here. I mean, I could redistribute the cosecant x, but that just gets me back to the spot I was. So now I'm going to look to my trig skills, and I see it's 1 minus cos squared, and we've seen that before, and anytime you see that variable term squared, you want to think Pythagorean identities, and that simplifies to be sine squared x, and this gets us exactly to where we were in the problem, or the other way that I worked this out. And now we can make this 1 over sine x, and then make this sine squared, and then the signs cancel, and we're left with sine x. There is actually one other way, I believe there might be more than one, but one other way that works through this. I like this method the best. I think it's the most efficient and elegant, but of course, you know, you do with what you got. If you didn't find this way, that's totally fine. But there's one other way where you take initially the cosecants and make them 1 over sines, and then you got to combine like denominators and do all that wonderful stuff. You can ask me in class, and I can work through that one if you want. Work through this again in that fashion. Okay, lastly, we have this happening where we have 3 trig terms within one whole fraction, and we want it to equal tangent. Obviously, we're going to work on the left-hand side. It's much easier to work with all this mess and try and make that tangent, right, rather than trying to make tangent into that. So I look at that and I go, okay, I have cosine times secant. And I think, like, what do I know about cosine and secant? Well, they're reciprocals of each other, and we're multiplying. So if I multiply reciprocals are like 4 1/4, 2/3 and 3/2. Anytime you multiply reciprocals, you get 1. Now, if you don't see that, you can go, okay, well, I am going to turn everything in terms of sine and cosine. Note, I'm not doing anything with even and odds. I don't have a negative angle. I'm not doing anything with Pythagorean identity because I don't have any squared terms. I'm going to go with turn everything in terms of sine and cosine. So I have that cosine, and now I'm going to turn secant into 1 over cosine, as secant in the numerator is cosine in the denominator. And note, it's still in the numerator of the large fraction. And I'm going to put that cosine theta over 1. And then that cotangent, I am going to go and make that cosine theta over sine theta, because that's the quotient identity that turns cotangent into cosines and sines. So now that I look at that, I go, oh, within this numerator here, I have a cosine theta over 1 times 1 over cosine, and these cosines cancel. So that leaves me with 1, and I have 1 over cosine over sine, which is the same as multiplying by its reciprocal, 1 by the reciprocal of that denominator. And that gives us that. I will do this one more time in a little different fashion.